Alright, so we've already worked on real-life situations with exponential functions, and we've also talked about the money part of exponential functions, which is great with compound interest, and hopefully you guys have your own bank accounts and you're getting that so you can put money in and start building up your accounts so you have money and all that stuff in the future. And hopefully you're thinking towards the future. But what we're going to do is we're moving into now the graphing part of exponential functions, because you need to make sure you know how to do that using tables. So our title here for this part is Graphing Exponential Functions. Alright, so this part here, we're going to throw in a brand new vocabulary word that's very vital for you guys to remember and understand. So we're called asymptotes. So the P is silent. So with that, it's asymptotes. Asymptote. And then make sure you don't say the bad word, because we don't say that word in here. Bad. Those words are bad. All right. So asymptote is a line the graph never touches. And again, there's all these formal definitions that you can have, but I'm making it as short, as simple, and easy. It's a line that the graph never touches. So when we graph these next parts, you should be able to see that the asymptote, and if not, we need to graph the asymptote that goes with it. So our first example in this section is going to graph f of x equals 5 to the x power. All right, now when we graph this out, we're always going to use the same exact numbers here for our x values. Every single time we're going to use the same exact values. We don't have to worry about this. We don't have to worry about them changing or flipping or doing something weird. But exponential, we use the exact same numbers every single time. So what we're going to do is we're going to graph f of x here, which is 5 to the x power. And each one of these, we're going to use our x values, and it always, again, it's the same. -3, -2, -1, 0, 1, 2, and 3. Every single time, it's the same numbers. So you can see it just like that. You use the exact same numbers every single time. Don't change. All right, so the next part is just substitute those values in for x for each one of these. Okay, so we just put them in. And now we need to go ahead and solve them out. Or simplify them, as you can say. Now, with it, we said this before, that whenever we have a negative exponent, that means we have to flip the number to make it a positive. And let's write this off to the side. When you have a negative number, or a negative exponent, say negative exponent, you must flip the number, the base number, the big number. You must flip that number, that base number, the big number, to make a positive exponent. You must do that. Okay, so to do that here, we're going to go ahead and make these here. So that means since these are negative exponents, we have to flip them. When we say flip them, we know there's an understood 1 underneath each one of these. Understood 1. And if there's an understood 1, what we're going to have to do is flip this part here to make it a positive number, or to make the exponent positive. So we flip this to make it 1 over 5. And all of this is raised to the 3rd power. we flip this one, do 1 over 5 to second power. Again, 1 over 5 to the first power. That always makes it a positive exponent. You always flip it to make it positive. All right, and then from here we're going to simplify everything down now. Now, also remember that whenever you have an exponent, it must go to the numerator and denominator, not just denominator. So this is 1 to the third power over 5 to the third power. Here this is 1 squared over 5 squared. Here this is 1 to the first power, 5 to the first power. And then simplifying it down last but not least, we do 1 over 125, because 5 to the third power is 125 here. Here, that's 1 over 25. And this is 1 over 5. Simple and easy. All right, here 0 to anything to a 0 power is equal to 1. And we talked about that on the warm-up. 5 to the first power is 5. 5 squared is 25, and then 5 to the third is 125. All right, also, I like to get decimals when it comes to these answers here, these fractions, because it makes it easier for me to graph them. Because I really don't know how to graph a fraction that well, because it really doesn't make sense like that. So let's go ahead and put the decimals here. So we put them into the calculator. We do 1 divided by 125. You get 0.008. Divide 1 divided by 25, that is 0.04. And then here, that is 0.2. Alright, so cool. Now the next part is to actually literally graph this out. So I'm going to zoom this out a little bit. Just a little bit. And I'm going to hopefully keep as much up here as possible. And we're going to graph this out on the graph paper. And again, like I said before, when it came to graphing the lambda problems, like graphing out those functions there, we have to make sure that we go by a certain increment here. It can't just jump like since you have like 0.8 and 0.4 and 0.2 and then 1, 5, 25, 125. You can't just jump like do 0.8, 0.04, 0.2, and so on and so forth. You have to have correct increments. So I'm going to do these by, I believe I said 25s before. So let's do 25s. 1, 2, 3, 4, 5. And actually, let me get some space between here. And with these, you can go by 25s, you can go by 10s, you can go by 5s, however you want to do it. Oop, I said, let me give you space here, and I didn't give a space. So space there, 2, 3, 4, 5. So that's 25, that's 50, that's 75, that's 100, that's 125. Alright, so on each side here, we're going to put our 1, 2, 3s and negative 1, 2, 3s here to match up what we did in our table. And we're going to plot the points now. And with these, we have like negative 3, which is our x, and our y value is 0.008. So we're going to plot that, negative 3, but we don't need to be perfect. We just need to make sure that we show that it's not 0, but it's not 1. So we need to make it really close to this x-axis down here. So as long as you show me that it's close to the x-axis, you're good. All right, the next one is negative 2, and that 0.04 right there. So negative 2 and that 0.04 is a little bit higher, so we just make a point that's a little bit higher than that. Negative 1 and then a negative 0.2 is a little bit higher than that one too. All right, at 0 we say it's at 1, so it's a little bit higher. At 1 we say it's 5, so it's another little bit higher. And then at 2 we say it's 25, so put it right there on 25. And 3 we say it's at 125, so that jumps way up here to this part here. And then we just go ahead and connect the points, making sure that we do not touch the x-axis. So it gets closer and closer to the x-axis, but it will never touch the x-axis. Never. So make sure it doesn't. But on the x-axis, we need to make sure we have our dotted line for our asymptotes. So we need to draw that on there. So if you have a colored pencil or something else other than that, use that. That's our asymptote right there. And from now on, whenever I say to graph this out, you need to make sure you have the asymptote. If not, it's going to be wrong. Completely wrong. So I'm going to get some color. Try to put some color on that one so that it makes it stand out a little bit more, because it doesn't stand out that well to me. So something like this. Yeah. There we go. That's our asymptote. Nice asymptote. Alright. So that's it. That's how you graph it. Alright. See you on the next video.